Okay. A warm welcome to all the members, and for the new members, my name is Purna. I'm an architect with 13 plus years of experience. Uh, in this session, we're going to look at again building loosely coupled systems or components. We already looked at some examples in the first session, first part. Along with that, we also look at abstract classes as well. This is the end of object-oriented programming principles. In the upcoming sessions, we'll look into the advanced concepts. So, agenda, as usual, would like our guys to master their coding and also crack the interviews around the concepts what we learn here. After that, we see some more use cases on loosely coupled systems or components, how we build, what tools or components we use in different applications in the world, basically. And they're very big concepts. We cannot see them in action here, but we'll give you an idea what can be used in building loosely coupled systems or components. In the first session, we had looked at interfaces to decouple classes or components, but in this session, we look at some more advanced concepts, the tools and utilities that are available. And then we will have a deep dive into abstract classes, and hopefully this session will clear you some misconceptions around interfaces and abstract classes, and I'm sure you will definitely clear any questions around abstract classes and interfaces from this session, because for many people abstract classes and interfaces are devil kind of interview questions, but after this you will be cleared. Let's move on to. So as I discussed, we are going to look at some of the principles, some of and the technologies that will be used to decouple the systems. Okay, so I got a couple of use cases here. First one, if you see, if you have any e-commerce application, you will be having n number of components in that one. You will have a logistics. That means once you place the order, you need to deliver that item to the customer. So there is a logistics involved. That means it might be through Blue Dot, or it might be through First Courier. It can be any courier system. Okay, and also you will have a billing systems, and you will have a email systems, SMS components, and you will have some other infrastructure related as well. So what I mean here by decoupling is you should be able to replace your existing systems with another system in case of any issue. If you do not design your application, or if you do not architect your application in such a way that it can handle disasters, like let us say if the workers from the Blue Dot are not available, they're on strike, what you can do, you cannot deliver you cannot deliver your goods or items to the customer. What happens if your email systems are down? Let us say you are using Amazon email system. What happens if it is goes down? And what happens if your billing systems are down? Let us say you might be using some Microsoft CRM, or you might be using some IBM products for billing related stuff. What happens if they are down? Okay, you may think that we cannot replace these systems with another system, because billing, it includes all financial information, financial rules. It's not easily it is not even advisable to replace a billing system with another billing system, because we cannot do that one. It's not as simple as to replace a email system, because you do not have any financial data, any customer data in email systems. But how you can handle disaster recoveries? Let us say your billing system is down, how you can still enable your customers to place orders on your e-commerce applications? How how you can hide the issues from the customer? how you can give the good look and feel, or uh, uh, good performable application to the customers. So we'll look into the some technologies, and let's go and see the next point as well. In-house email components or systems we just discussed. We should be able to either replace the existing email systems, or we should be able to still enable your customers to place the orders, and they should not be aware of the issues with the email systems. Later they should be able to receive the emails. Even now, it may not be instant, it may take 1 or 2 minutes or 3 minutes, but still the customer should be able to receive the emails, confirmation emails, even the systems are down. And all of our guys are using smartphones. You have your Facebook, WhatsApp, and many other applications on your mobile devices. So you are receiving notifications every time when a friend is added, when somebody is tweeted, when you receive a new message in WhatsApp. All you are getting messages in terms of notification on top of the mobile device, or in the middle of the mobile device, somewhere else. We call them as push notifications. I guess some of my team members here on the meeting are knowing about this one, but still, please don't get repeat, don't think it as a repeated stuff, but others do not know. So these are push notifications basically. So the push notifications are being delivered by Apple, Google, Windows. Everybody is having their own components to deliver the push notifications to the mobile devices. And also, I don't think many of you are aware of this last point, that is decouple authentication mechanism from your application. Let us say that you are having a web application or web service or RESTful service, anything. You probably used only one authentication mechanism. It can be forms authentication, it can be custom authentication, or it can be passport authentication or Windows authentication. Most of you guys might have used only one authentication mechanism in your existing application. But I would say we should be able to decouple our authentication mechanism as well from our applications or services. Uh, one point, you might have heard of SiteMinder. You might have heard of OAuth. You might have heard of OpenID, and many social web applications also providing authentication mechanisms. So how you can decouple, let us say my current application is using forms authentication, but because of some scalability issues, or because of some business requirements, I wanted to go with the SiteMinder authentication, which is basically SAML2, based on SAML2. How I can replace? If I tightly coupled my authentication mechanism, I cannot use other systems. So we should be able to decouple authentication mechanisms as well. Okay, these are a couple of use cases in loosely coupled systems, but these are not the end of the story. There are many more as well. First, let's look at the technologies that enable us to build loosely coupled systems. So the first point we talked about decoupling logistics components or building systems from our web application or e-commerce front-end application. Uh, Probably you guys heard of Service Bus. Azure, there many people are providing service buses. Microsoft Azure is having their own service bus. Amazon is having their own service bus, and IBM is having their own service bus. All these components will provide the same functionality, but on different technologies and different behaviors, basically. So when my logistic systems from Blue Dot is down, what happens. So usually if your application is not decoupled, your web application or your end user will see an error, or they may see some message which can be currently our logistics system is down. There might be a delay in delivering goods to your address, uh, which is not good actually. So if you display such kind of messages, your customer lose reliability in your system. So instead, we should hide those errors. What we can do here, when you place an order in your e-commerce application, Amazon or something, you should not be invoking the methods or services of Blue Dot or some courier system, because that is where you got the problem. If the system is down, then immediately you will get an error. Your web application will get an error. So what should we do is we should bring a broker in between your web application and the third party component like a Blue Dot logistic component. What we can do here, we can bring a service bus. So your front end application is submitting uh, order information along with addresses to the service bus, and on the other side your Blue Dot system is listening to the orders that are submitted to the service bus. So in this way, your front end, your e-commerce front end, and the courier system or logistics system, both are decoupled. And you have another system called Azure Service Bus or Amazon Service Bus or IBM Enterprise Service Bus or BizTalk. You can use based on requirements. Okay, you can keep that component in between these two. So one system is submitting the request, orders some information to the service bus. The other system is listening to those messages. So your service buses are built on highly powered hardware and highly scalable systems, and they have a automatic scaling, scale up and scale out as well. So you don't need to worry about the scalability of the systems. So even the Blue Dot system is down, your e-commerce web application still works because you submitted your order information to the service bus, not to the Blue Dot. See, like this you can avoid disasters in your e-commerce systems or any other systems in case of any failures in the third party components where you do not have any control over that. In the same way, let's look at your push notification services. Basically, if you're an Android developer or iOS developer, what you do, if you let us take an example of Apple device. You developed an application, you want to create push notification services so that uh, your app users will get notifications when something happens in your application. Let us say you got a friend request or somebody left your group, you will get a notification on your device. So uh, uh, a couple of years ago, how it used to be, Apple is having a service that is Apple push notification service. So the mobile developers directly used to use that service to send push notification. So your mobile app directly connect to Apple push notification service. So that's well and good because Apple push notification services are built on sophisticated systems, and mostly they are available 5/9 availability. Like they might be down hardly 1 minute in a year or 2 minutes in a year, so it is not visible to the end user. But what about our application? Let us say your mobile application is built on a small server. It may handle only 1,000 push notifications per minute or per second. What happens if there is a surge in number of users? So if you get millions of users in a day, your server where your app is deployed cannot handle that kind of message inflow, so your system will go down. So how we can handle? Again, in the same way, in the first scenario, we have used Azure Service Bus or Amazon Service Bus or IBM Enterprise Service Bus. There are many such that. Even for push notifications also, now we have a luxury of using third-party services. Here, Microsoft, yeah. Can you hear me now? Okay. Sorry, there is a disturbance. Okay. So in push notifications, Amazon is providing Amazon SNS, simple notification service. At the same time, Azure is also providing push notification services. In the first scenario, we are directly consuming Apple push notification services to deliver push notifications to the mobile devices. Now, in order to decouple that one, what we do is we use the service of Amazon simple notification service to deliver message to the end user. So you can submit millions of end users can do some operations. All those notifications will be delivered to the Amazon simple notification service, and from there it will be delivered to the Apple push notification service. From there it will go to the end user devices. So that's it. You have built loosely coupled push notification services as well. So now your system is highly scalable. So basically, why we decouple the systems? What's the need to build loosely coupled systems? It's all about scalability. We just talked about it. Disaster recovery. It's all about highly performing applications. If you cannot decouple, you cannot handle disaster recoveries. You cannot handle the, high volume requests or high volume users. So likewise, you need to find out relevant systems to decouple your up components from other component. You need to find out the possibilities of failure. You should not have a single point of failure. If you do not have a, let us say, if you do not have a service bus between your web front end and the blue dot component or any other logistic component, your system will fail to deliver the courier details to your logistic system. Okay. Likewise, there are many technologies, many tools and utilities available over internet. Hundreds, I can say. So you need to analyze based on the need and based on your cost. You should be using some systems, some technologies to decouple your components. Uh, that is something about loosely coupled systems. And also, one famous thing what I forgot to say is service oriented architecture. This is one of the best mechanism. It is basically a methodology. Service oriented architecture is a methodology. It's not a technology. So if you implement your logic or your requirements in terms of services, your systems are more loosely coupled. So when I say services, it can be a web service, it can be a RESTful service, it can be any service, so that your logic is not inbuilt in your front end application or in your component. Your services can be hosted in different servers which are highly scalable. If you do not have hardware, you can go to cloud, public cloud. So concentrate on service oriented architecture as well. There are if you are a senior guy, people will stress you on service oriented architecture. It is a very big concept. There are many things involved in defining service oriented architecture. in upcoming sessions we can talk about them in detail, and we can also talk about on Azure service space or Amazon service space, and we can talk about many public cloud concepts as well in the upcoming sessions. So with that, I can say we can close the loosely coupled systems or components use cases, and we can move on to the abstract classes. Okay, I'm sure many of you guys know a lot about abstract classes, uh, and you are definitely using abstract classes in your day-to-day life, or many of you guys might haven't used abstract classes. uh, it doesn't matter whether you used it or did not use it, you always get confused between abstract classes and interfaces. uh, it's because lack of basics, because we don't spend much time on learning the basics, but from this session we should be able to clear all those misconceptions. So in the first part we looked at interfaces. If you remember, if you recollect, interfaces are useful when you want to decouple your classes or components. If you recollect the second session, we were loading classes and DLS at runtime using reflection, so that your front end is not modified in order to load different classes based on the need. So we effectively loosely coupled the components or classes in your front end. Uh, in the same way, abstract classes, sorry, it's not the same way. Likewise, abstract classes can also be used, but it is not to decouple the classes, but it is to use the common functionality across all your child classes. Uh, it can be act as a base class, which can have some common functionality, so that your child classes do not need to again implement or define the functionality. Okay, let's take let's go through these points, and we can get into the code as well. The first point, if you see, uh, it promotes reusability through inheritance, as it should be used as a base class. If you look at this point, an abstract class should be used as a base class, because you cannot create an instance of an abstract class. Why you cannot create an instance of abstract class? If you take the term abstract itself, abstract is something is not real. Okay, if you look at the class is a physical file. It is something, it has got some concrete information, concrete methods, so that you can create an instance of that class. But abstract class, it is not real, it has to be inherited by something, so you cannot create an instance of an abstract class. So as I said here, it promotes reusability through inheritance. So you have an abstract class which is a base class, and you have your child classes. Okay, the child class should inherit the abstract class, so you have some common functionality. In the first session we looked at Airtel SMS connector and Vodafone SMS connector, and at runtime we used to switch between Airtel SMS connector and Vodafone SMS connector, because the reason was, if one system is down, we are bringing up the other system. Don't you think we should need some notification system there? Let us say we are using Airtel SMS connector, it went down. We should be informing some administrators of our application, and administrators are responsible persons of Airtel SMS component as well, so that they can take some actions to make changes and bring it up back. In the same way, if your Vodafone system SMS connector is down, again we need to send some notifications to the administrators of your application, and responsible persons or administrators of your Vodafone customers as well. So you see, there is a common functionality between these two classes, Airtel SMS connector and Vodafone SMS connector. That common functionality is sending notifications to your administrators of your SMS connectors and the web applications. So this functionality, send notification to admins, can be written individually in your SMS classes, or you can define one base class, put this common functionality in that base class. Here we can make it as abstract class. We can put this in abstract class. uh, we will look abstract classes can be used to implement polymorphism as well. In the first session we looked at the polymorphism. We looked at static polymorphism and dynamic polymorphism. Static polymorphism is based on the signatures, and dynamic polymorphism is at runtime. That means you have a base class and you have a child class. Based on the child class, the functionality will be invoked. Let us get into action. So I have one. So I have created one class library. Here we have a SMS base class. So it contains one method, that is send email notification to admins. I told you this is a common functionality in the child class. When one of your system is down, the front end can use this method to send the notification. And you see, there is one more method, send SMS. This is basically which sends the SMS to the customers. So it is an abstract. It is an abstract class. That means you do not have a so an abstract class should not have a method definition here. That means if I try to create some definition here, then it will give me an error. Let us see. See, I got an exception, that is send SMS cannot declare a body because it is marked as abstract. As I told you, abstract classes or methods should be implemented by derived classes. So here I marked this method as a send SMS, but this is an abstract method, so I cannot give a implementation here. So it is just a prototype. So it has to be implemented by your derived classes. Because why I marked this send SMS as an abstract? Because your Airtel component might be having some set of steps to send SMS to the customers, and your Vodafone customers might be having some set of steps to send SMS to the customers. That's the reason, because different components use different steps, but the purpose is same. So we marked it as an abstract so that individual components can provide their own functionality. So if I come to uh, the client here, so let us see some action here. So I'm going to execute. So I'm going to execute my Airtel SMS customer send SMS method here. So I have sent SMS. SMS has been sent from Airtel Airtel successfully. You see, I have another output here. Output is from method bst. Okay, sorry, let me close this. I basically have many things here. Let me comment out these things so that I can explain one by one. So basically, if you try to create an instance of abstract class, let us say my abstract class here is a SMS base class. You cannot create an instance of abstract class as I told you earlier. Let us see in action. See, I I'm not able to create an instance of my abstract class because it is abstract. It doesn't have a fully implemented functions. You see, cannot create an instance of the abstract class. The reason it has got some incompleted methods. You can create an instance when your class is fully functional. Okay, uh, and also uh, so this is a point I was talking about. An abstract class indicates that class contains missing or incomplete implementation. Abstract methods, you cannot create abstract method as private. So let me build it. You see, there are many errors. Airtel SMS connector doesn't implement inherited abstract member. There is no suitable method found to override. If you see this abstract class, SMS based class, is implemented by Airtel SMS connector, Vodafone SMS connector, and these classes are using send SMS method. Okay, since I made it as a private, those derived classes are not able to access this class. So you should, so that's the reason your abstract methods or classes should always be public. It cannot be private because someone is inheriting. Okay, and also you cannot mark an abstract class as virtual. So the reason, see, if you see there, the abstract method cannot be marked as virtual. The reason, in first session we talked about virtual. Virtual means it can be overridden by derived class. Okay, and abstract also means it should be implemented by some derived class or some child class. Both are having the similar meaning. That's the reason we cannot duplicate. So an abstract class cannot be virtual. At the same time, you cannot create, you cannot have a abstract class as a static. See, you still have an error here. Virtual or abstract methods cannot be private or cannot be static also. You see? See, again, you have many issues here. There is no suitable method found to override. Virtual or abstract members cannot be private. So the reason, static has got the different meaning basically. Static means it will only create one instance of that variable or one instance of that class. That's what static means. Uh, but if you look at the abstract class, it will be implemented by multiple child classes. If you have a child class 1, child class 2, child class 3, all these classes are being derived from your abstract class. Okay, but when you make it static, static means only one. So both are having opposite meanings. Your derived class, your abstract class is supposed to be derived or implemented by multiple classes, whereas static means only one instance. Both are conflicting. That's the reason we cannot use static as well in your abstract methods or abstract classes. So we just we just uh, we just had a look at these points. Uh, Abstract methods cannot be private. Abstract members cannot be virtual. And also, please remember one point. Virtual methods run slower than your non-virtual methods. Let us say you have one abstract method or a virtual method. Uh, Let us say sum of two numbers. If a virtual method sum of two numbers takes 1 minute, or sorry, 1 second, then your non-virtual method or non-abstract method, which again does the same thing, sum of two numbers, it takes even less than a second. Because you can understand why it takes. If it is a non-abstract or non-virtual method, it can directly invoke the method. If it is a virtual or abstract method, first it will go and look into your base class, and then it will go and actually invoke the method in your child class. There are traversing mechanism that's why it takes more time. Okay, and also your abstract classes cannot be marked as sealed class. So you cannot have a sealed class. See, I cannot mark my abstract as a sealed class. See, an abstract class cannot be a sealed class. The reason, what do you mean by sealed class? Sealed means it will stop the inheritance. That means you have a base class and you have a child class 1 and child class 2. Okay, your child class 1 is inherited from base class and your child class 2 is inherited from child class 1. So in base class you have a method 1. That method 1 is implemented by your child class 1. If you want to stop further inheritance from child class 1 to child class 2, that means if you want to stop child class 2 to override the virtual method, then you can use sealed keyword. So it stops the inheritance actually. So we will see that in action in the later session. So abstract means inheritance, but sealed means stop inheritance. That means that's the reason we cannot mark abstract classes as sealed classes. Okay, uh, guys, all these things looks simpler, but I'm going to show you one use case now. Probably you might haven't seen so far in your experience. Okay, before that use case, let's look at some differences between abstract classes and interfaces, because the other use case might take 10 to 15 minutes to explain you. Okay, the differences. Abstract classes can have abstract members and non-abstract members. As we've seen, we can have some common functionality in our abstract classes. That's the reason it contains abstract and non-abstract. Interfaces, there is no common functionality. It is only method signatures or member signatures. Okay, and in abstract class, it can be in abstract class you cannot have a private or static. Uh, but if you look at the interfaces, all the members of interfaces should be public. Okay. Uh, Another very important difference, if you see the last difference, abstract classes can add more functionality to its child classes without spoiling their older version. Let us see in action what I mean to say. Abstract classes can add more functionality to its child classes without spoiling their older version. Whereas in interfaces, if you add any new method to your interface, then your application will fail. compilation will be failed, because anything in your interface should be implemented by your child class. Let us see in action. So for that, I have created one base class here, uh, that is just a base class. It contains currently one non-virtual method and one virtual method, if you see here. And I have a child class 1, which is overriding the virtual method of base class. Base class, if you see, there is a virtual method. It is overridden in child class 1. If you see, base class is a parent class for child class 1. I have overridden this method. And child class 2 as well, I have overridden the virtual method of your base class, child class 1. Let us say I build this one. Okay, let us say, let me comment this one. I was trying to create an instance of abstract class. That's why the compilation is failed. Let us say in my base class, I'm going to add one more method, that is public void uh, new new method. If you see, I am new method. So as you know, this base class is being implemented, derived by child class 1. Okay, but what happened, I added a new functionality to the base class, that is new method. Okay, now let me compile. See, my build is succeeded. Even though I made modifications to the base class by adding additional functionality, still my application works. Still there are no compilation errors, even though the base class is derived by some child class. That means uh, any additions to the base class will not uh, will not make a problem to the child classes. Your application will still work. That means you can have another child class which can have uh, so your first child class 1 is implementing only one method, is using only one method of your base class. You can have another class which can make use of all these two classes. That means you can have your child classes can make use of different versions of your base class. So adding functionality to the base class will not have any effect on your child classes. Whereas an interface, let us say I create one interface. So it is having some wide test method. We need to make it public, as you know. Let's build it, and let me have another class for testing purpose, that is child class 1. Let me implement this interface 1. Now I am implementing this interface here. So that's good. Let me build it. See, I created one interface, and I implemented this interface in class 1. Now let me go and add one more new feature to the interface 1. Let us say test method 1. And you see, I'm not going to implement this test method 1 in class 1. Now let's build it. See, I got an error. Class 1 doesn't implement interface member. That means you cannot, if at all you add a new feature to your interface, you have to change all your classes that implement this interface. That means you cannot have you cannot have interface alone changed at different timings in different sprints, I can say. Remember one thing, if you think that you might be adding or you may add new functionalities to your base class in future, then you can prefer abstract classes or base classes than interface. Interface is good for decoupling the classes, but if you are expecting any changes in future, then I would advise to go for abstract classes. But again, if you are having the both the needs, decoupling the classes and are subjected to the changes in future, then you probably mix and match interface and abstract classes. So it's all logical. Okay, this one is good. Okay, so this is what the last difference in your abstract classes and child classes. That is, abstract classes can add more functionality to its child classes without spoiling their older version. So you can add a new functionality, still your child classes will work in case of abstract classes. Interfaces, if you add a new functionality to your interface, then it has to be implemented all by its child classes. That means you cannot make changes. So you cannot have a versioning. Okay, all the child classes of your all the classes that implement interface will have all the methods, whereas in abstract class, different child classes of your base abstract class can be using different versions. Means one child class can use 2 methods, the other child class can use 3 methods. There is no restriction on that one. So those are the differences. And I was talking about one very important feature of abstract classes, which you might not have heard of it. Okay, that means what's that feature basically? Let me close all this stuff. So so far we talked about the features that are well known to you, but I just repeated. But this thing is not known to you basically. An abstract class can be a derived class. As I told you, abstract class should be a parent class, but it can also be a derived class. That means it can also act as a child class of some base class. How? Okay, in previous sessions, you have seen polymorphism and inheritance. Okay, how it works basically. Let me go by some examples so that it will be useful to you. So in this example, uh, I'm going to explain plain polymorphism and inheritance, and as well as the latest one. So in general polymorphism, how it works. So this is a kind of a multi-level polymorphism, and after this I will show you in abstract classes. So I have a base class which contain it is a plain base class. I have one non-virtual method, and I have one virtual method which is marked as virtual, and I have another method, new method. Okay, and this base class is being derived by child class 1. If you see, child class 1 is derived from base class. In base class you have virtual method which is marked as virtual, so I have overridden this one here using override keyword. Let's go to child class 2. Now child class 2 is derived from child class 1, not from the base class, and I have overridden the method virtual method. If you see, I do not have any virtual method in child class 1. Do I? No. I do not have any virtual method in child class 1. Then how I am able to override some method of child class 1 in child class 2? Because this is a multi-level inheritance. Your base class is having a virtual method called virtual method, and in child class 1, so let me show the hierarchy here. Uh, so this is how it looks. This is your base class, and then base class, and this is your child class 1, and this is your child class 2. Here you have a method called virtual method. So through multi-level inheritance, I have a child class 1 implements base class, child class 2 implements child class 1. Through inheritance, child class 2 is able to override the method in base class. Okay, you remember that one. Through child class 1, I am able to override the method in virtual method in base class. At the same time, my child class 2 can access all the public methods in base class. Okay, now let's see here. So this is very important, guys. Please remember what I am saying, because in the next topic, it will be useful. Okay, now what I'm going to do here, I'm going to showcase, I'm going to execute these methods. Okay. Okay, guys, I guess my voice was breaking. Now, let me take. Hope this is clear now. Okay, to demonstrate that one, what I am doing here, I guess only one guy is having the problem, Sachin or someone. Please, can you look at your internet connectivity stuff? Okay. So let's examine this polymorphism or inheritance here. So what I done here, I have I have this variable of this base class, and then I'm creating an instance of child class 1. That means let's look at this here. So your now your your object is child class 1, if you see. Okay, let's go and execute this virtual method. So which virtual method is executed? The virtual method in your child class 1. Perfect. Remember here, I have created an instance of child class 1. Okay, but your variable is base class. Now your base class object is having a reference to your child class 1. That's why I am able to execute a method in child class 1. Let me do the same thing in child class 2. Remember, child class 2 is derived from child class 1, not from the base class. Child class 2 is derived from child class 1, not from base class. Okay. let me show you in action here what I'm trying to say. Obj child class 2. If I click on dot, see the first method what I have is virtual method. If you look at the description here, virtual method in base class. Okay, because your base class, your variable is of base class type, but instance, we create an instance of child class. Since this is design time, it will still since this is design time and this variable is of type base class, your method is showing as in base class, virtual method in base class if you look at the description. And the next method, non-virtual method. This is also non-virtual method in base class. This is at design time, okay, means compile time. Okay, so as at the design time, the virtual method is pointing to the virtual method is in base class, but at runtime it will change. Let's see that one. F11. So see, even the design time, my variable was pointing to the base class virtual method, but at runtime, my control flow went to child class 2, right? So that means what you understand here, what you should understand here, in inheritance or in polymorphism, at runtime, okay, uh, in other terms, whatever is the object of the class we created should be executed at runtime. That means if my object creation is for child class 1, then at runtime I should be executing the methods in child class 1. If my object is at for child class 2, then my methods in the child class 2 should be executed at runtime. Okay, but at design time it will still show as the methods in base class because objects are created at runtime, not in the design time. So now you remember, even though my instance type is a base class, at runtime my flow is going to the child class 1 and child class 2 respectively. So this is what everybody knows, but I'm going to show you a different way using abstract classes. Guys, hope you are clear. Hope you are clear. Now let's go to the abstract class. For abstract class, what I have done, so I have created one abstract class called abstract class base and derived. Okay. In this example, I am going to take three classes. One class is BSNL telecom lines. This is a normal base class. BSNL telecom lines. It is a normal base class. We are going to use it as a parent class. It contains one virtual method, that is a BSNL telecom provider, and non-virtual one normal method, that is non-virtual method. And I'm having one abstract class which is basically is inheriting from BSNL telecom lines. As I told you, an abstract class can also be a child class. So I have inherited a BSNL telecom lines, which is a parent class in abstract class. So since your parent class contains one virtual method, that is BSNL telecom provider, it should be overridden in the child class. So did I overridden here? No. Basically I should be overriding this BSNL telecom provider method, which is in parent class, but I did not override here because I did it in a different way. I need to have some abstract methods as well in my abstract class. So what I did here, instead of overriding this BSNL telecom provider method, I made it as an abstract class. And you see, along with the abstract keyword, I also used one more keyword, new keyword. This is what I'm going to explain now. Let us, for the time being, let us remove this new keyword and try to compile. See, I got some warning here, that is BSN to make current member override the implementation, add the override keyword, otherwise add new keyword. It is telling me either override this one or use a new keyword. So I want my abstract class to be a parent for another class. So I don't want to override this BSNL telecom provider here. Instead, what I do is so I have used a keyword called new abstract here, and this abstract class will be derived by some child class, that is child class geo SMS connector. If you see, my child class is derived from abstract class, and I have overridden the method BSNL telecom provider in child class. Let me open this one. This is BSNL class, and then I have abstract class, and then I have child class. Okay, so why I have draw this diagram here? In first diagram, I'm a child class 2 is able to override a method in base class, because child class 2 is inherited from child class 1 and class 1 is inherited from base class. But here, base abstract class is inherited from BSNL class and child class is inherited from abstract class. But what happens here is something different. I will show you now. In terms of output, okay. Uh, Here what happened, if you create an object of, okay, whatever, if you remember here, now if I'm again repeating this one. I'm again repeating this one. In the first example, where you do not have abstract classes, if we create an object of child class 1 of type base class, then the methods in child class 1 will be executed. If we create child class 2 object of type base class, same base class, then the methods in child class 2 will be executed. That means whatever is the object you are creating, the methods of that objects are getting executed. Okay. In the same line, you think the same thing. If I create an object of child class, then the methods in child class will be executed. That's what you think. But it is not going to happen like that. Now see what happens. So let me first execute this scenario. The scenario is BSNL telecom lines, which is my parent class. It is a normal parent class, and I am creating an instance of child class geo SMS customer. SMS connector. If you see, child class geo SMS connector is derived from abstract class. Okay, but as per inheritance, I can still use BSNL telecom lines as a base class of this child class. because of this inheritance. So for child class, this is also base class and this is also base class, 3 inheritance. That's why I'm creating an object like this. And now let me run this. Guys, you just see the object here. Now the object is of child class geo SMS connector. Let me go and execute this F11. See where I have come here. I have come to BSNL telecom lines. I have come to parent class where I am supposed to go. My flow is supposed to go to child class. Mean I am supposed to execute the method BSNL telecom provider which is in my child class. But the flow went to the parent class BSNL telecom lines, which is exactly opposite to what we seen here. In this scenario, if we create an instance of child class 2, then the methods in child class 2 will be executed even though it is of type base class. If I create an instance of base class child class 1, then the methods in class 1 will be executed. Whereas here, I created an object of child class, but the methods in the child class are not executed. The flow is going to BSNL class, which is a parent class. See, this is my parent class. See, my output is from the method BSNL telecom provider in BSNL telecom lines base class. Why? Why? Why it did not execute the methods in the child class? Why it executed the methods in the base class even though I created an instance of the child class? The reason here I will show you now. What's the reason? You have in the abstract class you have marked this. This is basically virtual method. BSNL telecom provider is a virtual method in your parent class. Okay, you are supposed to override that here, but instead what you did, you have used a new keyword and you marked it as an abstract. Now what happened here, when I created an instance of this child class of type BSNL telecom lines, what happened here, first it went to the parent class first at runtime in JIT compiler. Basically when I created this one, since it is having some parent class, uh, it is of type this one, it went here and then it tried to look for this method. This method is marked as virtual. That means it is overridden by some child class. That child class is child class geo SMS connector. Now what happened, your your inheritance is not directly from BSNL class to child class. This is from BSNL class to abstract class. So now the navigation is like this. First the control has come here, BSNL telecom lines, and the method is BSNL telecom provider, and the method is marked as virtual. It is trying to find out the child class. In the inheritance, next thing is it comes to the abstract class. Now the control has got shock because there is no method BSNL telecom provider which is overridden, which is having override keyword. So since there is no overridden method BSNL telecom provider, so the control has stopped here. So since there is no way for it to find out the child class, it has stopped here itself, and it executed the method that is available in the base class itself, that is BSNL telecom provider. But actually as per inheritance, uh, the method in child class should be executed, but because of the abstraction and because of the hurdle in base class, that is a new keyword, it stopped here, the flow stopped here itself, and there is no method to be executed, there is no method is found to be executed. So the flow went back to parent class here and executed this method. That's the reason. The culprit here is new. Instead of overriding this method BSNL telecom provided, we provided a new behavior to this method. We did not override. We made it a new behavior. So your control flow stopped. That is the reason the method from base class is executed rather than from the child class. Okay. In the same way, the abstract class. Now what I do is, if you remember in the inheritance, your child class is derived from abstract class. Your child class is derived from abstract class. Okay. That's the reason what I did. I created an instance of this child class of type abstract class, and you see here now I'm trying to execute access the BSNL telecom provider. You see the description here what I written, abstract method BSNL telecom provider. So it is point to the abstract class method BSNL telecom provider in abstract class, and and I am accessing a few other methods as well. Forget about this one. So as per inheritance, when I create an instance of child class, the method from child class should be executed, but it is going in opposite way. F11. See output. Just a minute. Give me a second, please. Okay. Uh, so here if you see, when I execute this one, the control is going to child class only. The control is going to child class only. Okay. So the difference here, I have written the entire description here as well. So what happened here, when you create an instance of your child class of type base class, the method in the base class are executed rather than in child class because of the new keyword in abstract class. The inheritance is not allowed. Your control is not flowing from your parent class to abstract class to child class. It is stopped here itself. So the method in the base class was executed, whereas in the second instance, the method in the uh, child class is executed because your flow is like this. The base class of this one is here, and it is directly having a link to your abstract class. Guys, uh, this is a tricky implementation in abstract classes in terms of stopping inheritance from multiple base classes. Frankly speaking, I never used it in my experience, but probably if you get a scenario like this where you need to stop inheritance from a parent class to child class, from you want to break inheritance between different parent classes, or you want to implement the functionality of in base class even though your instance type is of child class, then you can use a new keyword basically. So that I have used here, new keyword. New is nothing but it basically hides the implementation of your base class, or it will provide new implementation to the virtual method, so it stops the inheritance there itself. Okay, that's what I wanted to talk about base class abstract classes in this one. It is little confusing in understanding this one, but after this class please take this recording and code and the PPT, please practice one time, please debug one time so that you can memorize. Frankly speaking, it took almost 2 hours for me to create this one. So please spend a couple of minutes after this session debugging this scenario so that you will better memorize this one. Guys, we'll meet you again in the next session that will be on solid principles. Let's have a look at this. So you have the use cases here. I already explained here common functionality and reusability through inheritance. Next session will be on solid principles, and from this session we will be in advanced concepts. So I wanted to clear this object-oriented programming principles before solid principle, uh, so that you will be comfortable in understanding solid principle. After that, we can get into advanced sessions.